Welcome all. Today's class is about projection of lines, and we can solve some problems including horizontal trace and vertical trace. Here is the first problem. Front view of a line AB makes 45-degree angle with XY line and measures 60 mm. Line's top view makes 30-degree with XY line. End A is 15 mm above HP and its vertical trace is 10 mm below HP. Draw projections of the line, determine inclinations with HP and VP, and locate HT, VT. HT and VT. Here, front view of the line makes 45-degree angle with XY line. That means that angle is equal to alpha. Alpha is given and that's equal to 45-degree. And measures 60 mm. That means front view, length of front view is equal to 60 mm. A dash, B dash is equal to 60 mm. Line's top view makes 30-degree with XY line. Line's top view makes 30-degree with XY line. That means that angle beta is equal to 30-degree. 30-degree. End point, locus of end point A is given. That's end A is 15 mm above HP. And locus of VT also given, that is 10 mm below HP. Then in this case, this is the step-by-step solution, step-by-step procedure. And here we have to draw the XY line first, XY line. Then we can locate the point A. That point A is 15 mm above HP. That means we can locate that front view of point A, 15 mm above HP. 15 mm above HP. This distance is equal to 15 mm. And we can't locate that top view of A because that distance is not given here. Then this distance is equal to 15 mm, 15 mm above HP. And we can locate that angle. Here alpha is given 45-degree and that front view, length of front view is given as 60 mm. Then we can draw the front view which is inclined 45-degree with XY line. Then we can draw the front view of the line, A dash, B dash, front view of the line. Then we can locate or we can draw the locus of VT. That's equal to 10 mm below XY line. The locus of VT is 10 mm below XY line. We can draw the locus of VT, vertical trace. And after that, we can apply the condition that front view, H dash and VT must be collinear. That condition we can apply here. Then we can extend this front view and locate H dash and VT. H dash and VT. H dash is that point where the front view intersect or the extension of front view intersect with the XY line. That point is H dash, and further extension, that extension line will meet the locus of VT, and that particular point will become vertical trace. That point will become vertical trace. Okay, in the next step, we can locate that V, point V, by projecting by drawing a projection line which is passing through VT, and we can find out that point V. Find out that point V. Then in the next step, we can draw the locus of top view. Here that top view inclined 30-degree with XY line. That condition is given, so that we can draw a line which is inclined 30-degree with XY line, which is passing through V. Because VHT and plan must be collinear. and we can locate that that top view by applying that principle. We can draw the 30-degree line. We can draw a line which is inclined 30-degree with xy line and passing through point V. In that particular line, that top view must lie. Top view must lie. Then only that beta angle beta is equal to 30-degree. Then we can project that h dash from the we can project that h dash, and we can easily find out ht. Then we can we can draw the projection line which is passing through A like this, and also we can draw a projection line which is passing through B dash. Then we can easily locate top view AB, top view AB, top view AB. Then by draw a projection line which is passing through H dash, and that will meet that locus of top view at a particular point, and that particular point will become HT. That particular point will become HT. That is the procedure to find out the HT, VT, and the top view and front view. Top view and front view of the line. Then by usual procedure, line rotation method or plane rotation method or trapezoidal method, we can find out the true length of the line. Here we can use the line rotation method, and we can draw the locus of top view of B and locus of front view of B. Locus of front view of B is this one, and locus of top view of B is equal to this one. Then by rotating that top view, or we can rotate that front top view in such a way that it's a top view parallel to xy line, then this point will become B1. Then AB1 parallel to xy, AB1 parallel to xy, which having the same length of top view. Then we can, by projecting this point B1 up to this the locus of front view, then we can locate a B1 dash. Then A dash B1 dash will become the true length. A dash B1 dash will become the true length, and the angle between that true length in front view and xy line will become true inclination with HP, theta. Then we can draw the same true length in top view also. Then we can locate point B2, or we can draw AB2, which having the same length as that of A dash B1 dash. This one true length, and similarly this one also true length. By drawing this top view, true length in top view, then we can find out that true inclination with VP, which is the angle between true length in plan and xy line. That is the final answer. That is the solution for the problem number 1. Okay. Here is the second problem. One end of a line AB is 10 mm above HP, and the other end is 100 mm in front of VP. Its front view is 45-degree inclined to xy, while its HT and VT are 45 mm and 30 mm below xy line respectively. Draw projections and find true length with its inclination with HP and VP. We have to find out this true length, then theta and phi, true inclinations with HP and VP. Here the given data is the inclination of front view with XY line, that's equal to alpha. Alpha is given as 45 degree, and one end is 10 mm above HP. One end is 10 mm above HP, and the other end is 100 mm in front of VP. 100 mm in front of VP. These are the data given. Then in the first step, we have to draw the XY line as usual. Then we can locate A dash 10 mm above XY line. We can locate A dash 10 mm above XY line. 10 mm above XY line, we can locate that A dash, front view of the end A, front view of end A. Then we can draw the locus of the other end, which is 100 mm in front of VP. We can draw the locus of end point B. Locus of end point B. This is the locus of small letter b and b2. Small letter b and b2. Then we can draw the locus of horizontal trace. HT and VT are 45 mm and 30 mm below XY line respectively. So that this is the locus of 30 mm below line. This particular line is the locus of VT, not HT. This is the locus of VT, and a line which is parallel to XY line and 45 mm below, XY line. That is the locus of HT. This is the locus of HT, and this is the locus of VT. This is the locus of VT. Then in the next step, we can draw the locus of front view. That front view is inclined 45 degree with XY line, so that we can draw the locus of front view like this. We can't locate B dash because that length is not given, but that B dash must lying on this particular line. That means that front view must be inclined 45 degree with XY line. Then we can locate that particular line. Then we can apply the principle of collinearity. We can apply the principle that front view, VT and H dash must be collinear. Front view, VT and H dash must be collinear. By extending this particular line, we can locate that H dash and VT. This is the locus of VT, and the front view or its extension, whenever penetrating the XY line, or whenever that intersecting with the XY line, that intersecting point will become H dash. Then we can project that H dash, and we can easily find out HD because the locus of HD is given. Then similarly, we can locate V also by projecting a projection line which is passing through VT, and this point will become V, small letter V. That intersecting point with the XY line will become small letter V, and similarly we can locate HT also. Then in the next step, we can say that V, HT and top view must be collinear. Then that top view must be on a line which is connecting V and HT. Then that we can draw that particular line which is passing through V and HT. Then automatically we can locate that top view like this. This is the locus of end point B. Then we can find out that intersecting point. Then another one end projector is passing through A dash that will intersect with this particular line at A. Then this point will become A, and this point will become A, and this point will become B, and that AB must be the top view. AB must be the top view. Then we can project that top view, and we can easily find out B dash like this. we can easily find out that point B dash. Then we can mark that front view in a by using a dark line like this. A dash B dash is the front view. A dash B dash is the front view. Then we can easily locate the or easily draw the locus of front view. Then by rotating this top view in such a way that that top view is parallel to xy line, then we can project that point, and we can find out the true length in front view by locating that point B1 dash, which is the intersecting point of that locus and this particular projector. Then we can find out that true length A dash B1 dash. Then again by rotating front view in such a way that that front view will become parallel to xy line, then we can project it. We can project that point, and we can easily locate the point B2 dash. We can easily locate the point B2, and AB2 will become true length in plan, and the angle between true length in elevation and xy line become theta. This angle will become theta, true inclination with HP, and the angle between true length in plan and xy line become true inclination with VP. Found out that true length along with theta and phi, true inclination with HP and true inclination with VP. This is all about second question, second problem. We have completed the entire orthographic projection. Third question, the same problem we have already done in the previous slide. Same problem, but we can use utilize the trapezoidal method to find out the true length of the line. These procedures are exactly same up to this particular stage. We have located the front view and top view as in the case of previous problem. Top view and front view we have already located. Then in the next step we can apply trapezoidal method. In the previous problem we have applied line rotation method. Then in this particular problem we can apply trapezoidal method. For that purpose we have to draw two perpendicular lines which is passing through endpoint B and A. Then we can mark the distance of endpoint B dash or front view of B from xy line. This particular distance of B dash from xy line. That means this particular distance we can transfer here. Similarly, the endpoint A is at a distance of 10 mm above xy line. That means we can transfer this 10 mm, this distance, from elevation to plan. That we can represent that distance here. Then we can easily draw the true length of the line AB like this. True length of the line AB by connecting that end points of the that projectors. Then we have already discussed that the meeting point of top view and this true length. Top view and true length will become HT. We have already found out that horizontal trace. Then for the counter checking we can extend that true length, and we can ensure that the meeting point of top view and true length will be that horizontal trace, will be that horizontal trace. Similarly, we can draw a perpendicular line which is passing through B dash. We can locate the true length in front view also by drawing perpendicular lines passing through A dash, and B dash, and by transferring the distance of top view from XY line. That means we can transfer this 100 mm distance, this 100 mm distance from plan to elevation. This distance will become 100 mm. This same distance we can transfer from top view to front view. Then we can locate that end point B. Similarly, this distance of A from XY line, that means distance from this particular point to A, we can transfer that distance in elevation. Then we can locate the end point capital A, that will become the capital AB will become the true length in elevation, by extending the true length, and we can easily locate the vertical trace. We have already located that vertical trace and we can counter check that the meeting point of front view and true length will become VT by extending that true length. We can find out that extension will passing through point VT. Okay, then we can find out the angle between true length and plan. And in trapezoidal method, that angle will become theta, true inclination with HP. We can find out that angle theta. And the angle between true length in elevation and front view, that angle will become phi. That is the true inclination with VP. In trapezoidal method. We can easily find out that phi also, and we can check whether this angles are correct, as in the case of the previous problem where we utilize the line rotation method. We can compare the answers. We can have already found out that true length is equal to AB. We can find out that AB from top view or front view. That also we can compare with the answer which is found out using line rotation method in the previous slide or previous problem. That's all about today's class. Thank you all.